Hello everyone, welcome back to my YouTube channel. So today we are going to solve problem number 3531, count covered buildings. Okay, so this question is asked in weekly contest 447 as well. So now without any delay, let's get started with this problem. You are given a positive integer n representing an n into n city. You are also given a 2D grid buildings where buildings of I is equal to x, y, which denotes a unique building located at coordinates x and y. A building is covered if there is at least one building in all four directions, left, right, above, and below. We have to return the number of covered buildings. Okay, so problem statement is very easy. Let's understand this with an example first. Okay, so here n is equal to 3. All right, so here see n is equal to 3 and these are the buildings. Okay, so let's say this is building A, this is building B, this is building C, this is building D, and this is building E. Okay, and let's say this is positive x-axis and this is positive y-axis. Okay, positive x-axis and positive y-axis. All right, so now here this building A is at 1 and 2. Okay, so this is nothing but x coordinate and this is nothing but y coordinate. Okay, so 1 and 2 here, so this is nothing but building A. All right, and building B is at 2 2. Okay, so this is building B. Building C is at 3 and 2. Okay, so this is building C. Building D is at 2 1 2 and 1. Okay, so this is building D, and building E is at 2 and 3. Okay, so this is building E. All right, so now here from this diagram, if you see this building B, all right, so if you see the upper side, so there is one building. If you see the right side, there is one building. If you see this downside, okay, so there is one building. And if you see this left side, there is also one building. Okay, so this building is covered in all four directions, right? In all four directions, left, right, above, and below, right? So this building is covered. Okay, and have here you see any other building which is covered? No, there is no other building which is covered from all four directions. So only building B is covered in all four directions, right? So that is why my output is 1. Okay, so only building 2 is covered as it has at least one building above, below, left, and right. Thus the count of covered buildings is 1. All right, and here constant size is very large. All right, tends to 5. Okay, and buildings dot length is also tends to 5. All right, and buildings of y consisting of x and y coordinate, and x and y value should be from 1 to n, and all coordinates of buildings are unique. Okay, so these are the constants. All right, so here see this example number 3 now. Okay, so example number 2 is very simple. Okay, there is no building covered here, and this is example number 3. Okay, so here one more point I want to show you. So here let's again name the buildings like A, B, C, D, E. Okay, now I'm going to do it quickly. Okay, I'm not going to waste much time here. So 1 3, so that simply means A here. B is 3 2, so this is B building. C is 3 3, D is 3 and 5, and E is 5 3. Okay, so here see this C building is covered in all four directions. Okay, from B, from A, from D, and from E. Okay, so here see this D building is here, so definitely this is going to be covered. All right, so it's not like if this building, so next building should be here, here, here. Okay, not adjacent. Okay, so it's good if this building is here, then also it is covered. Okay, so that's important point. Okay, so treat this as important. Okay, this point. And okay, so here now from here output is 1. Okay, that is clear. Now from here, if you see, if I see this side, okay, if I see this side, okay, this line, all right, so here in this line, this is the first coordinate. All right, so definitely if there is any other building here, let's suppose, and here, then this is going to be the mid of this. Okay, so this is nothing but boundary point. Okay, here this is also nothing but boundary point. Here also this is nothing but boundary point. Okay, boundary point if you see from here. Okay, so this is the first building that you see from top. Okay, this is the first building that you are seeing from here. Okay, so this building is definitely covered if I just see this axis, right? Same way, if you see from here, this is the first building you will see. If you see from this side, this is the first building that you will see. Okay, in this line, and inside this you will not be able to see any other building. So definitely all these are covered, right? Okay, so here what I'm going to do, I will find out for all the axes, like for this, okay, for this axis, for this axis, for this axis. Okay, whatever the first building is there, whatever the first building is there. Okay, I will find out that. I am going to say initially that all the buildings are covered, and from here I will drive the logic. Okay, so here let's suppose there is one building here. Okay, there is one building here. Let's say this is building A. All right, there is one building here. Okay, so now here let's say this building is C. Okay, so from here C, you want to find the coordinate here in this direction. Okay, this is nothing but the x-axis. Okay, so in this direction you want to find the coordinate which is furthest to this one. Okay, so you want to find the coordinate like this one. All right, so let's suppose if there is one coordinate here, this is one coordinate here. Okay, and from this C you just want to find out this coordinate. Okay, not this one, the last coordinate from this side. Okay, the max coordinate from this side. Okay, this is what you need to find. So here you are looking in this direction. Okay, in this side. So here you will get some max value, right? Some max value. So in this side I will take the mean value of x-axis. Okay, so mean value of x-axis I will say that I'm going to take 0. Okay, done. All right, so here what I'm doing, I'm going to track the leftmost x. Okay, track the leftmost x for each y. Okay, for each y I'm going to track the leftmost x. Okay, so here for this I'm going to set all the values to 0. Okay, of my all the buildings. Okay, so how many buildings here? 1 2 3 4 5. All right, so for all the buildings I'm going to set this value to 5, 0 0 0. Okay, I'm going to find the rightmost. For let's suppose this is A building, B building, C building, D building, E building. All right, so for all these buildings I'm going to find the rightmost, and in all these I will assign 0 0 0. Okay, so now for this building, okay, I want to search the coordinate here. Okay, I don't want to search here. So from here what do I need the minimum value. All right, so I need the minimum value, right? From this to this I need the minimum value, right? Okay, so here in this side I'm looking now, so definitely you are going to looking from here, so you will see this building first. Okay, but for this particular building C I want to find this value. Okay, so I don't want this, I want this value. Okay, so here that simply means I am searching for the minimum value. All right, so if I am searching for the minimum value, so I am going to assign max value here. All right, so okay, so here let's understand it like this. So in many coding problems, if I ask you that from this array you have to find out the minimum value, so what you guys do, you create one variable C, and in this C you have to find a min, but in this C you write max. Okay, in this C you assign integer dot max underscore value, right? And then you are going to compare integer dot max dot underscore value with this 2. So 2 is min, so 2 is your current output, right? And then after that you are going to compare this 2 with 3, then again 2 with 4, then again 2. Okay, but you have to start from max, right? If you want to find min. Okay, so that's the reason. So here in this, for all the buildings A, B, C, D, E, I will assign here max value. So max value here n is equal to 5 now, 5 into 5. So here let's do one thing, let's assign 666. Okay, I need max only, right? And definitely the building will be from here 1 to 5 only, right? So here I am assigning max value 666, right? So this is going to track the leftmost. Okay, leftmost x for each y, for each y. All right, so I'm going to take find out like that, right? Okay, so for this particular building C, what is the last building in this, last building in this, same way in the upper direction also I need to check. Okay, in this direction also I need to check. Okay, so this is the first thing that you have to do, right? So once you are done with this, you find this, then it's very easy now, just iterate from for over all this building one by one. So first this is a building, okay, 1 and 3. So here 1 and 3, that simply means A building here, A is here 1 3. Okay, so for this you will, this is your coordinate x and y. Okay, so for this building you will already have the values, like what is the this side value. Okay, what is this x left side value and x right side value. Definitely you will have also y left and y right. Okay, so let me show you. Okay, so first thing, x left, you are going to initially set all the values to n plus 1 6. Okay, max value we are taking, so x left is equal to 6 6 6 6 6 6. Okay, so I have already explained why we are taking 6 here, right? All right, so this is for left side. All right, in which we need what minimum value, right? So we are assigning max, and here this is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index. Okay, so since we need values until 5, so n plus 1 is going to be size, right? So, all right, so and I'm assigning the max value, right? And here this building doesn't make any impact because we have the buildings from 1 to 5. Okay, so we are just using these coordinates 1 2 3 4 5, but when we initialize array, so we have to take 0, right? We are taking it from 0, starting from 0, right? So that's why I'm going to operate this as well, right? But it will not create any impact. Same way you have to create x right, y left, and y right. All right, so this is the first thing that you have to do. Then after that you are going to process each buildings. All right, so here first you are going to place this building, A building, so 1 3, so 1 and 3 here. So for this building, if you see right now this is the only building, right? So here x left. Okay, so here in the x left side, in the here see this coordinate, so only 1 is there, right? So I'm assigning 1. In the right side also, this is going to be the rightmost building, right? So here I'm writing 1. And in the left side, okay, so if you see in the left side you can say 3 only, right? And because this is the only building right now, okay, and here also you can say 3. Okay, y left of 1. So here what are these two values? Okay, I'm passing. So this is nothing but you can say x of left of this 3 value and my current coordinate x value, right? And this is nothing but you can say right x right of y and my x coordinate, right? So here I'm updating the right boundary for y, all right? And here I'm updating the left boundary for x. Okay, so here this is nothing but y left of x, y left of x, all right? And here y, okay? And here I'm writing y right of x, and here I'm writing y. Okay, so here I will also show you how this is going to happen, right, in the code. So we are just going to store the building like this. Okay, for next building is this 3 2. Okay, so now more things will be get cleared, right? So 3 and 2, here I will place this building. So here uh, this is one axis and this is one axis. Okay, so in this axis I have to now validate few things. Okay, here I'm placing B building, right? So here for this, okay, so x left, so see this side, so here you have to just place 3 only. In this whole side there is no other building, so just place 3 only, right? Now y left you have to place. Okay, so there is just one building, na same way you have to place here 2 and 2. Okay, y left, okay, and y right also 2 2, right? Now here you are going to place 3 3. Now here you are placing building C. Okay, so now see carefully what is going to happen. Okay, this is building C you are placing. So here in this side there is one building at this one. Okay, so that is means x left is going to become 1. There is no impact here, so it will remain 3, right? And now here see y left. Okay, so y left, how we are going to place now y left? So y left here mean 2 and 3. So here this side I'm taking, so mean value is this side is 2, right? Upside is 2, so I'm taking this. And here in the bottom there is no other building, right? So 3 4 5, there is no other building here in this direction. Okay, there is no other building, so this C itself is the max value at this point. So here I'm writing 3. Okay, so this is nothing but my x left. Okay, this is nothing but my x right. That simply means the furthest building in this side. This is nothing but above side y left, furthest building in y left side. And this is nothing but y right, the furthest building in the right side. Okay, this below side. Okay, this one side, right? So this is what we need to do here, right? Now this is clear, right? This is what I'm doing here. Now here let's move the page to this side. So here next time we are placing the building D 3 5, 3 here and 5 here. Okay, D here. Now in this side there is nothing, right? So just it will remain 3. In this side there is nothing, so it will remain 3. Now in the top side this B is the building. Okay, so 2 we will update. In bottom there is nothing, so here I will write 5. Very easy, right? Now it is becoming very clear, right? And here 5 3. So a little bit tricky but very important question. Okay, so here building E. So in this side building at 1. Okay, in this side there is nothing, this itself. Okay, so 5. Now here in the upside there is nothing, so this building itself 3, and bottom there is nothing, 3. All right, so in the end if you fill all these values like x left of 5 index, okay, so in the end after processing all the buildings, this is going to be your x left array, y right array, x y left array, and y right array, right? So here starting from this we have updated all this by processing all the buildings one by one. Okay, this is done. So this is the next thing that you have to do, and then just iterate over buildings. Okay, so here for building 1 3, x is 1, y is 3. So now just compare it with x left, x right, y left, and y right. Okay, so we will check one condition. Okay, so here see this building is not covered, not covered, right? So here see this is false, this is also false, this is also false, right? Only this is a true. Why this is true? Because in the right side there is one building. Okay, for this building there in the right side there is one building, but here in this left, in bottom the right, and in this left there is no building. Okay, so all the conditions are coming as false, right, except this. So that's the reason. Then building 3 2, so all the conditions you will place check. Okay, so for x I'm checking, maybe there will be some x left to value, right? So right, so what I'm making sure here, okay, like this is the right. So here let me show you the correct output, like here 3 3. Okay, so here this is a 3 3, right? 3 3. So here this is nothing but x coordinate, this is nothing but y coordinate. So I want one value here, right? And I want one building here, I want one building here, I want one building here. So here see this x is greater than the x left of 3 value. This 3 is greater than the 1 value. That simply means that there is one building here, because here it is 1, right? Our 1 was here, 2 was here, 3 was here. So here x left value of 3 at this 3. Okay, at this 3, right? So there is one value, right? So that simply means here this is greater, right? And this 3 it should be smaller than this. Okay, so 3 is less than 5. So here was one building was there. Then here in this side we will check. So here in this side there is one value, right? At 5 there is one value here, there is one value here. Okay, so that's what. Okay, so here this is x left, now one value here. Okay, one value here. Here we have value at 2. Okay, so this is the case for y. So this is for y and this is for x. Okay, sorry for confusion. For this is y, this is for y, and this is for x. Okay, so this is what we need to check basically. And in the end, the building is not covered. So when all the cases are true, then only result will remain same. Okay, otherwise if any value is false, then decrement the result. So in the starting, we take the value of result as a maximum value, right? Maximum number of buildings. So in the end, I just decremented it to decrement, right? After processing all the buildings, I will see that my result is 1. So after processing all the buildings, the result is 1, the meaning that one building is not covered by its neighbors. That's it. Okay, so now let's write the code. So here x left is equal to new int, all right, and here n plus 1. All right, so here let me do one thing. I will write the comments as well so that you guys get a clear idea. Okay, so it is going to tracks the left most x for each y, for each y. Okay, and now let me just copy this, paste it here, and here this is nothing but take it as x of right. So x of right is now going to track the rightmost x for each y, and here take it as y left, and it is going to track the leftmost y for each x. Okay, so in upper direction. Okay, in upper direction we are checking this, right? Left. And here y right is going to track the leftmost y rightmost. Okay, so here this is leftmost and this is the rightmost. Okay, this is going to be the rightmost y for each x, and this is nothing but lower side. Okay, lower side we are checking, right? And you have to take the total for the total number of buildings. Okay, total is equal to buildings dot length. All right, and now after that you have to initialize the arrays with the default values. Okay, so here basically zero index will not create any effect, so I will do one thing. I will start with 1 only. Okay, and here I is less than equal to n, and here I plus plus, and here inside this right of I I'm going to set all the values. Okay, in the right to 0. Okay, so in the right we are going to find out the max coordinate, right? So I'm taking the min value here, right? So here right of I 0, and same way left we want min, so that's why I'm going to start with max. So in the max I will start with n plus 1. Okay, n plus 1. All right, so this I'm setting to minimum value. Same way for y right. Okay, so this is write it like this now. This is for x right, and this is for x left, and r make it capital, and l make it capital. And same way just copy this and paste it here, and here just make it y of right, and here make it y of left. This is done. All right, so until here I hope everything's clear, right? We are not doing anything complex right now. Process each building to update the min max values for rows and columns. Okay, for int building in buildings, inside this x coordinate we have to take. So here building 0, and here y coordinate building 1. All right, so now we have to modify left boundary, right boundary for x and y, right? So what I'm going to do here, x left of y. Okay, x left of y. Here I will write we need min side or min value, right? Math dot min of, here I will write x left of y. Okay, and current value of x coordinate, right? So this is going to update the left boundary for y. Update the left boundary for y. Okay, right, now same thing you have to write it here. Let me just copy this, paste it 4 times, 1 2 3. Okay, so here now here you have to write x of right y. Okay, so x of here change it to right. Okay, so here x of right y is equal to math dot, in the right side you have need max value. Okay, so here max, and here you have to write x of right y, and here same it will remain x. So we are going to apply the right boundary for y. Okay, here right boundary for y, right? And same way here you have to write y, and here you have to write left of x. Okay, so y left of x, copy this Okay, in the upper side if we are going, so we need min value, right? So here just paste this, right? We need min. Why min? Because here we are starting 1 2 3 from here, right? So we need min in this side, so upside, right? So here y left of x, and here you have to write y. Okay, and this is going to update the left boundary for x. Now it is going to update the right boundary for x, and here you have to write y, and here right of x. Okay, so here y right of x, copy this, paste this here. Okay, same thing that I explained on second controls. And what happens here, y right of this, and here you have to write y. That's it. Okay, this is done, right? Now let me just format the code, right? So now after that, what you need to do here, take one result value, okay, in the result, and here just pass the total. Okay, what is the total, current total? So initializing the result with the total number of buildings, then we have to iterate through the total buildings to check if they are covered. Okay, so now just few lines of code, that's it. And here building, and here buildings, all right. And here inside this, take same now, copy this, why waste time, right? Copy this, and here you have to just check the condition. Okay, so your x value, so this should be greater than x left. Okay, it's clear, right? It should be this x left of y, right? And same way, and x it value, okay, current coordinate, it should be less than this x right of y, right? Same way, and your y should be greater than this y left of x. Okay, y left of x, and here this y should be less than this y right of x. Okay, y right of x, right? So this is done. Now here inside this, if this is the case, right, then just continue, then we don't need to decrement the count. But else we have to decrement the result by 1. Okay, result is equal to minus equal to 1, right? And in the end you have to just return the result. That's it, return result. All right, so see, very small code, right? Here I have to update it to max now. I didn't update. Now let's run it. Code is very simple, you just have to practice it. Okay, so just practice this question maybe after 2-3 days one more time, right? Now let's submit it, and the time compressed is going to be O of n, and this O of m, right? So O of n plus m, you can say. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you, bye bye.